So let's take a look at the possibilities with this Laffer curve idea in a specific case. So we have t, tax rate, little t, is something between 0 and 1, and the tax revenue, capital TR, is a result of that tax rate. And I built a potential form. So the tax revenue equals 40t minus 80 times t squared. Remember, t is the little t, the tax rate is between 0 and 1. So what you wind up with, if the tax rate is 0, little t, then tax revenue is, plug in the little t, is equal to 0. If you raise that tax rate, say a little bit to 0.1 or 10%, then the tax revenue would be 40 times 0.1 minus 80 times 0.1 squared, and that would generate $3.2 in tax revenues. On the other hand, if you raised it some more to say 0.5 or 50% tax rate, then what you'd get for tax revenue would be 40 times 0.5 minus 80 times 0.5 squared, and that would again get you a tax revenue of 0. Not exactly what we want, but what we want to do is find some sort of intermediate ground. This is what a graph of this tax revenue would actually look like. So if we're trying to decide whether if tax rates went up, would that imply that tax revenue went up or that tax revenue went down? Similarly, if you lowered the tax rates, would tax revenues go up or tax revenues go down? And that's the interesting question. That's the question we have to be asking ourselves. Well, in order to establish that, what we first have to do is determine where are we on this curve. So this is T star, the tax rate that maximizes tax revenue, the extreme value. The reason we want to know that is if the current tax rate is less than that, the slope is positive, and by raising the tax rate, you'll actually increase the tax revenue. On the other hand, if we're above that point, the slope is negative, and lowering the tax rate would raise tax revenue. So the question then becomes, where are we? What is the value of T star, little t star, and therefore, what should we do with our tax rates to increase revenue?